welcome back to this 12th edition of BIOVISION Forum. You can see it everywhere. There's more and more attendees. More than 1,200 people are here. They are attending to the plenary session, the workshops also, and the speech. So many things all in common as one place and One Health. More than also 150 speakers. One of them is Jean Ponce. Jean Ponce is the head of the joint ENS and INRIA and CNRS project team. It's Willow ENS. What is it exactly?
So I'm a professor at École Normale Supérieure, and I'm the director of the computer science department there, and it's a joint lab between ENS, École Normale, CNRS and INRIA. And INRIA is the institute specialized in computer science and applied mathematics. And within that lab, I also direct the Willow team, and the Willow team is dedicated to research in computer vision, which is my specialty. Computer vision is the art, if you will, of automatically understanding the content of digital imagery. So pictures, videos, recognizing people, these kind of things.
Oh, so now in the e-health programs, you are in the artificial intelligence, which is the main topic that we will talk after in the plenary session. They ask it as a title, as a generous revolution serving health. Is it serving health really?
So I'm here a little as a foreigner because I don't work on biomedical applications at all. On the other hand,
but you're a professor, so
yeah, and so I have things to say. And on the other hand, our research is indeed in artificial intelligence. We build the perception system for intelligent machines. So of course I know a bit about artificial intelligence, and so I don't know much about the biomedical applications, but it's clear that there has been an artificial intelligence revolution going on in the last 4 to 5 years. You know, the field has existed for 50 years now, but the revolution is fairly recent. And so there have been many applications in many domains. And of course, there's a biomedical domain, but you can think of robotics, the automated.
They all succeed, or?
Well, so artificial intelligence had its ups and downs. It had a winter in the 90s where the discipline didn't work so well. But with the advent of new scientific progress, new techniques, new algorithms, and at the same time the availability of massive data and the computing power that's increased a lot, things that didn't used to work at all now seem to begin to work. So yes, things do work. They do not work perfectly, and that's something that people should understand. An AI program will deliver an answer to whatever you are asking to it, but this answer will be right some of the time, not all of the time. So it is doing things that nobody really imagined would be able to do a few years ago, but it's not perfect. So,
but can you give us an example for the large public to understand what a new robot of artificial intelligence can do? I mean, there's some of them who can measure the pollution of the atmosphere and clear it and have the database. Is that it, or there's some other example in health?
I mean, some examples of success is, if you use Siri on your phone or Alexa or these kind of systems, systems that can understand speech and natural language. Those are successes of artificial intelligence. If you look at automated cars that are not quite here yet, but will be here very soon, and there have been many companies have been experimenting with them. Cars are also an example of applications of artificial intelligence. So for example, in health.
Is the revolution still getting longer or something?
Again, I'm not so much involved in biomedical applications, so I cannot say something really smart. I know the big companies are getting into health applications.
But there's an influence on health. I mean, if you take electric cars for the pollution, I mean, there's a direct influence on health.
Sure, there's an influence on health, and there's automated cars, automated trucks that will come around soon. They will have influence on pollution, especially if they're electric, I gather, and they might be more efficient. So there will be an influence on health. There will be more efficient, hopefully, use of many things. So there will be an effect on health, but also there is help to diagnostic, help to semi-automated analysis of medical images. That's coming. Um,
Is there a gap between the product and the large people? I mean, I can see you took the example of the electric car. Okay, the electric car will come up soon, and still we can see some models which are prototypes. How come the most of the population can use in Europe, for example, or in France, or in Lyon, here in Lyon, can use those models, can pass through this technology to help people?
well, I think the delay between research and applications to the general public is always there. It's getting shorter and shorter. There are some issues of, say, certification, for example. So now you can have cars that more or less drive themselves. But, just like cars that are driven by people, they will have accidents. So how do people accept them? What's the regulation? What's the responsibility when there's an accident? And this is true for cars, but if you have something that's trying to help a doctor do a diagnosis, there's a question of responsibility and reliability and all that. So there's always a delay in there. I think an interesting application to healthcare is medical robotics. So I think that's been one of the big success of robotics. If you look at Da Vinci surgery robots, those are wonderful machines. But they have essentially no autonomy. It's a doctor driving them, so they are not intelligent in a real sense. And then people are also talking a lot right now about robots for assisting fragile people in hospitals and all that.
Okay, last question, Professor. You are also the author of Computer Vision, a Modern Approach. It's a textbook who's been translated in Chinese, in Japanese, and in Russian.
That's correct.
What is the key thing that everybody wants to learn that you can resume?
I think that, again, nowadays there's a huge interest in industry. So all the big American companies want to hire PhD students and all that. So I think there's a very large interest in industry, even in everyday life, for artificial intelligence in general, computer vision in particular. So yeah, the book was kind of successful for a textbook.
To be neuro-intelligent. Thank you, Professor Jean Ponce, so the head of a joint ENS and INRA and CERENES project and the Willow team for the ENS. Thank you. And we'll catch you on BioVision, this 12th edition of the BioVision that you can follow in the hashtag BioVision, but also on Twitter. You are many followers here to follow us. New guests will come and take your place. Thank you.